Question 18. This is quite a challenging question, but doable. You have an outboard motor attached to a boat, and this boat is unusually fixed to a certain structure such that the boat cannot move. So when the motor is started, the motor will push a stream of water backward. This propeller will exert a force F on the stream of water, forcing a cylinder of water backward. So if we apply Newton's second law, F equals to ma, we can write force equals to m times change in velocity v minus the initial velocity, which is 0, over t. So you may be wondering, what is this initial velocity 0, right? That's because the water initially has a velocity of 0. Then it is being pushed as a column of water towards the right. So this column of water has a velocity of 10 meters per second. So there is a change in velocity of water uh, as it accelerates from 0 to 10 meters per second. Then I will now modify this equation. Referring to the cylinder of water, the mass of this cylinder of water is equal to the density of water times the volume of the water cylinder, then multiplied by V divided by T, right? Then I can actually put in more values. So volume is actually area pi r square of that cylinder of water times a certain length, right? In a certain time. This length is the length of the water column in time t. Okay, so I specify that in time t, I have a length of water column. So I multiply by V over T. So this will give me density of water multiplied by pi r square, and then L over T is none other than velocity. Okay, so substituting the values, I have 1000 multiplied by pi, r is 0.1 square, and then L over T is velocity. So velocity multiplied by velocity, I have 10 square. So using the calculator, I get a force which is 3140 Newton. Okay, so that's the force that is pushing the water or accelerating the water, and as a result, you have a column of water moving backward. The question says, what is the average power of the motor? So that is the area of focus, average power of the motor. If you use the formula P equals to FV, then you have to modify this equation because P is the instantaneous power, that is the power when the water is at velocity V. So I have to modify it by using average power. Average power is equals to force times average velocity. Okay, so this force is 3140, and then the velocity, since the velocity started from 0 at the start to a certain velocity v, so I will take the average velocity, which is 10 plus 0 divided by 2. Okay, and that will give me the answer 15.7 kilowatt. So the answer is C. Okay, that's the end of the discussion for this question.